Hi everyone. I'm Nikunj. I am co-founder and CEO at TrueFoundry. And TrueFoundry is an ML infra startup helping companies build generative AI applications which are production grade. My prior background includes leading one of the conversational AI teams at Facebook, now called Meta. And prior to that, I also led one of the machine learning teams at a startup called Reflection, and obtained my master's from Berkeley. I did my undergrad back in India at IIT Kharagpur. So we will try to make the talk interesting, where in some cases we'll kind of share some technical details, and how you use different types of LLMs. And in some cases we'll also try to, for the most part, we'll try to keep the talk at a relatively high level so that we are able to understand the economics around large language models. So the question that we're trying to answer today is, this is whether we are going to spend $360,000 or $3,600, right? So that's what we're going to answer today through this presentation. And before we get started, there is one thing that I want to call out is this presentation is not going to be too technical about large language models themselves, but for the most part, it is going to be a math and economics presentation. Okay. And of course, the reason we put up these two numbers is because for pretty much the same task that we are solving using large language models, we can either incur this cost or this cost, which is obviously 100x or 2 orders of magnitude different, depending on what type of model and what type of mechanism we choose to solve this problem. So it's really important, the point that we're trying to make here is it's really important that we understand how the pricing and pricing around LLMs work, and what are the different options that we have available in front of our hand, right? So that we can take those informed choices in some way. And to make this real, let's actually talk about one of the specific problem statements that we'll use throughout the slide, to basically figure out the cost dynamics. And we choose a data set that all of us are familiar with, which is Wikipedia. And let's assume that we are solving a very simple problem, which is we want to summarize Wikipedia to half its size. So we take all the English articles in Wikipedia, this roughly 6 million articles. Each of them have close to 1,000 tokens, and I've taken some artistic liberties here to make the calculations easier. And our goal is to reduce this Wikipedia 6 million articles, 1,000 tokens each, to 50% of its size. So 6 million articles, but 500 tokens each. So roughly, we are taking a 6 billion token catalog of English text and trying to summarize that to a 3 billion token summary overall. Okay. And please keep the session interactive. So if you all have any questions, feel free to put it on the chat and I will answer it as we go. Would love to keep the session as interactive as possible. All right. So let's take a look at our, and one other thing that I just wanted to call out is, while we are focusing on the cost aspect of running LLMs, and we will have some examples of the quality trade-offs as well. The exact choice of LLM would depend on a lot of other factors, right? Latency, do you want open source, closed source, what type of traffic pattern that you are seeing, what type of quality that you want, what's the skill level of the development team working on the problem. So there's a lot of other factors involved. So don't get me wrong, this is not the only criteria, but one of the important criteria that a lot of us are not paying enough attention to, right? So that's why I wanted to just bring out the cost and economics aspect to the life, basically. So let's do a deep dive into one of our favorite models, GPT-4, and to the problem that we are trying to solve, which is summarizing Wikipedia, right? Now, the way GPT-4 is priced is, it kind of has two main levers. And by the way, here I'm making some assumptions that you are at least somewhat familiar with how you interact with one of the large language model. So you would be sending out a prompt, which is like some question, some task that you want the LLM to achieve. And in return, you're going to get a response from LLM. So in our example, we give one Wikipedia article with some prompt that summarizes it to half its size. That's going to be our prompt. And the summary, that is the 500 token summary that we'll get, is going to be our response, right? And the way GPT-4 is priced is looking at the length of your prompt. So how many number of tokens in your prompt, and the length of your response. So how many number of tokens in your response. And by the way, token is a technical word here. It is It's like, think of this on an average, that it's a little bit smaller than an English word on an average, right? So roughly one token is 3/4 of an English word, to be precise, by the way. Now, the way they price it is, if you are processing 1 million tokens of prompt, right? So in our case, 1 million tokens is roughly 1,000 Wikipedia articles. You are paying $30 to OpenAI. And if you generate 1 million tokens in the response, you're basically paying $60 overall. So you could argue that like summarizing 1 million of these articles would be $30 plus $30, which is $60. So roughly, we're looking at the total cost. If you do the math this way, you will notice that your prompt processing cost will come out to be $180,000, and response processing cost will be $180,000. Of course, response is half its size and double the cost, so the two prices are similar, are the same, and the net cost that we are paying is $360,000. So this is step number one of, you could choose your default model GPT-4 and use that to summarize your Wikipedia, and then you pay $360,000, right? And by the way, this is with GPT-4, the 8K context length variant. There is another variant of GPT-4, which is the 32K context length variant. And the way this is priced is exactly twice of the 8K context length. So you pay $60 per million tokens for prompt processing and $120 per million tokens for response processing. So of course, your net cost that you're paying is $720,000. Okay. On the other hand, there's much more amenable pricing if you're using GPT 3.5 Turbo, and they have recently reduced the price quite a bit. So you would roughly be paying $15,000 compared to $360,000 if you choose GPT 3.5. Now, obviously, you're taking a little bit of a quality hit when you go from GPT 4 to GPT 3.5. But what you need to evaluate is, for this task of summarizing Wikipedia, is GPT 3.5 good enough? If yes, then suddenly you are looking at 20x lower pricing overall, right? Now, the same task can be solved by, call it the cousin brother Anthropic, right? Anthropic, the Claude 2 model. And in this case, like a lot of people choose Anthropic partly because of the very long context length. So 100K context length. So for example, like you could be summarizing 100 Wikipedia articles at one go, right? Now, in this case, the cost that you're paying is roughly $162,000. So fairly low compared to GPT-4, and much higher if you compare to GPT 3.5 variant. Now, obviously, Claude 2 is their top of the line model as well, right? On the other hand, if we switch gears and we look at some of the self-hosted 7 billion models, right? So let's say you used a Llama 2 7 billion model, right? What would you be paying? And of course, in this case, your pricing levels are very different compared to how GPT-4s and dollar priced, right? So the way you would be calculating the price is based on how much infrastructure you're using. And to compute the infrastructure cost, you essentially want to estimate how long will it take for Llama 2 7 billion to process your 6 billion tokens of prompt and 3 billion tokens of response. Now here, one interesting fact to notice is large language models are really good at processing prompts really fast, because they can actually like parallelize the prompt processing. So you would notice that per second or per minute prompt processing is actually a lot more than your response generation, because that happens more sequentially, right? But net, the cost that will come out to be would be like roughly $2,100. And again, I'm using some approximations here in terms of the machine pricing based on availability, on demand, spot instances, etc., to kind of make the calculations a little bit easier. Of course, one caveat I want to call out is it's not a fair comparison to compare a 7 billion model with GPT-4 or GPT 3.5 or Claude, right? The point that we will be making here is, you just need to decide what size of model, open source, closed source, self-hosted, API driven, is something that works out for you. So these are the different options that are available. They may not be like apple to apple comparison, right? But roughly, we're looking at $2,100 of similar of cost to do the same job of summarizing Wikipedia. I'll just quickly, before we get into fine tuning, I'll just take a quick look in case we have any questions, and we do not. So we move ahead. Okay, now we're looking at let's add fine tuning to the mix. So what happens if you are fine tuning some of these models? Now, OpenAI makes GPT 3.5 available for fine tuning, and the way we are thinking about formulating this fine tuning problem is you would, let's say, fine tune the model for Wikipedia dataset. Again, don't try this at home. It's already trained on Wikipedia, but this is more of an academic exercise to estimate the cost, right? So you would fine tune it on that dataset, and then you would use the fine tune model to summarize your Wikipedia. That's what we're looking at, right? Now you would notice that the cost of prompt processing is a lot more for the fine-tuned model compared to the pre-trained model, right? And the same thing for your cost of response processing. So net, the cost of processing summarizing Wikipedia using a fine-tuned GPT 3.5 turns out to be $168,000. This is in comparison to the to $15,000 benchmark that we just saw earlier, right? Now, at this point, I want to ask one more question to you all. So we already have some understanding of how the cost scales when you're fine tuning, let's say GPT 3.5, right? $15,000 becomes $168,000. Now I'm going to ask you the same question. So we saw that if you used an open source self-hosted model, it was costing $2,100, right? So the question that I'm going to ask you all is how much would be the cost if you used a fine-tuned version of the open source model, right? And I'm going to give you a few options. So let's say, all right. Let's see. So we see it costs $2,100 to summarize Wikipedia using 7 billion self-hosted model. How much would it cost if you used a fine-tuned version? Are you all able to see the poll? Let's wait to get some responses back here. All right. So we show the results. Some of us estimate, we have varied estimates here. But turns out that the actual cost when you use a fine-tuned model instead of a pre-trained model scales to roughly $3.6K compared to a $2.1K, where you just simply add the cost of fine-tuning itself, right? The training cost, which is $1,500 or $1,500 on Wikipedia dataset. Turns out that the cost of serving, that is the inferencing, does not change at all if you are self-hosting the model, which is also intuitive in some way, because if you're anyways hosting the model, it doesn't matter whether you're hosting the pre-trained model or different weights that are fine-tuned to your application. But when you think about an API provider, if they have a pre-trained model, it's the same model that's getting used across millions of their users. Whereas if you're fine-tuning it, they have to host that part of the model for you yourself. So the cost really scales when you use an API provider. So again, one other factor to consider when you're choosing your LLMs is, do I need to fine tune? And if I need to fine tune, then can I justify the cost if I use an API provider versus should I do it myself, basically, right? So that's the other thing that you should consider. Just putting it all together in one slide. A few things just to notice. Of course, cost increases 2x if you're increasing the context window size. So again, think about whether you need that long context window, or for the most part, you're fine with a smaller context window, right? Then fine-tuned GPT 3.5 is roughly 10x more expensive, 9 to 10x more expensive if you are using like a pre-trained version of GPT 3.5. So again, think about whether your application needs fine-tuning or not. And self-hosted models, like the fine-tuning does not change the cost too much. And if your task can be done with a smaller model, most likely you will end up saving a lot of cost if you ended up using a smaller model for that. And by the way, for Wikipedia summarization type of task, this actually is true. We have tried this at home and it works out quite nicely for the summarization. Okay. All right, now let's take a look at some of the quality benchmarks here, right? So the question is, and by the way, here we are using Llama 2, but something very similar would hold if you are using Falcon or Mistral. There's a lot of these other good open source models, different variants, and of course, there's a lot of charts available outside to compare their performance on benchmarks. But here we are using one standard model, one standard task to go through some of these examples to bring these concepts to life, right? So now Llama 2, we notice that it beats the ChatGPT 3.5 in some tasks and comes really close in others, right? It beats its other open source cousin Falcon models practically on all of the metrics, you would notice, right? And it does not on an average, it's not on an average is able to beat GPT-4. So GPT-4 stands much superior compared to Llama 2. And in general, it is fairly good for agent or retrieval augmented generation type of tasks, basically. Okay, let's look at that with a few examples. So we are comparing Llama 2 performance compared to GPT-4 for a few tasks. So here the prompt that we gave is we have a bunch of people coming from different cities, and we just asked it to do a named entity recognition that tell us the name of people who are residing in San Francisco. Both Llama 2 and GPT-4 are able to pick the right names from this. So good, overall good named entity recognition. The next bit is, let's make it a little bit more complicated. So let's assume that we are asking it to do format a text that I've provided into a structured JSON format. And besides the caveat of the tool that's giving us not so well formatted, not so pretty looking JSON, the response both from Llama 2 and GPT-4 are exactly the same. Both of them are able to do this formatting task quite well. Okay, the JSON structuring task. And on the other hand, if you give it a long document and you asked a bunch of questions, right? So this is a long ML documentation that we have provided, and asked it a bunch of questions, specific questions. We see that both Llama 2 and GPT-4 are able to pick up the right answers from this long document that we provided. Okay. So at this point, we may ask that is Llama 2 really so good that it's almost able to match GPT 3.5 for GPT-4 or GPT 3.5 performance on most of the tasks? And the answer is no. It's good in some of the tasks like named entity recognitions and formatting and stuff, but it's not so good with coding and math. And again, benchmarks would speak to that it falls behind even GPT 3.5 quite a bit in both coding and math as well. Okay. And again, we see that with a few examples. So in this case, this is actually a fun prompt that we gave to Llama 2, where we kind of tricked it with saying the diameter of a circle is twice its radius, which is just a fact, right? There is no information in that statement. Now, I asked it, what do you think is a circumference? So ideally, it's a simple question here is, what's the formula of the circumference for a circle, right? But we tricked it a little bit. And we noticed that Llama 2 actually gives us an incorrect response, which is 4 pi r, where the expected response is supposed to be 2 pi r or pi d, right? So GPT-4 does not get tricked with this, but Llama does get tricked. And same thing, we ask it some simple math questions like multiplication, and this gives an incorrect response compared to GPT-4, and then here's the right response. So you don't have to do this math in your head. Okay. And we also tried it some code generation, where we asked the Roman representation of the number 15, and Llama 2 generates a code where it gives me 4, the Roman representation of 4. On the other hand, GPT-4 is able to give me the correct response overall. Okay. So we see a bunch of contrasting examples where in some cases it works, in some cases they don't. Now the question is that the cases where they don't work, can fine-tuning solve the problem, right? So that's what we want to figure out. So it turns out at TrueFoundry, we did this exercise where we tried to make Llama 2 good at multiplication, the multiplication example that we saw, right? So we programmatically generated a bunch of prompts and completions. And in this case, the way we generated these completions are literally how you would teach a kid a long form multiplication, right? And with that, it took us maybe 4 hours to fine tune this model, and costed less than $5, right? Net. And with that, you would notice that when I asked it the same multiplication question now, the fine-tuned version is able to come back with the correct response, that is 45816, whereas the pre-trained version is giving me some arbitrary response, right? And by the way, that's the other thing. You keep asking the same question, and it's very likely that it will give you different responses unless you ask it to be very precise with its calculations, by the way. On the other hand, somebody in the community ran this very interesting exercise. So a lot of large language models are quote unquote censored in some way because they want to be safe, right? They don't want to be misused. Now, there are some applications where you may want to, take more artistic liberties here, right? For example, you may be writing a creative piece, let's say some horror, thriller, and stuff like that, right? And if you ask it to generate, more explicit pieces, your typical large language models would back off, especially Llama 2, because it's really fine-tuned for safety. And in that case, it kind of starts bordering with helpfulness in some way, right? So somebody from the community, what they did is they took a bunch of data, which is almost uncensored, and they fine-tuned Llama 2 to become uncensored in some way, okay? And we at TrueFoundry reproduced their experiment in-house. And again, this fine-tuning maybe costed close to $30 or so. So not very expensive, because again, you don't need a lot of data to fine-tune this model, right? And in this case, what we saw is we tried it with a few examples. So I'm going to be participating in a comedy roast. Can you give me some hilariously spicy roast? And you would notice that the uncensored version of Llama 2 generates a lot more, call it a meaner responses compared to your pre-trained version of Llama 2. Although it gives you an answer, it's it really reduces the intensity of the roast, if you wish, right? And again, in some cases, people may want to have more explicit roast in some way. Tell me different ways to break into a car. I can't think of a practical application why you would want to do that, but turns out that the uncensored version is giving you this response, whereas the censored version is giving you an instruction. I cannot provide you with instructions on how to break into a car, as it is illegal. So it kind of gives you that ethical lecture in some way, right? And of course, there's a lot of work that's been done from the community where they evaluated the fine-tuned model quality compared to the GPT 3.5s and GPT 4s. And if you're fine-tuning models for and by the way, this work is from MoveWorks, and this is I'm not associated with MoveWorks in any way. It's just literally a good work published in the community. So I'm sharing some of the results here. Where you would notice that in some cases it actually beats GPT-4, even few shot learning. So you would notice that 0.98 compared to 0.73. Whereas in some cases it comes really, really close. So very small 7 billion parameter model that's fine-tuned to a specific task is able to get to very close performance to GPT-4 few shot learning. And which is why, by the way, I picked 7 billion model in the beginning when we gave those examples, because we have seen that at that level, once you start getting 7 billion range, fine-tuning becomes extremely effective at solving some of the tasks. So we personally have seen people saving a lot of latency and a lot of cost if they decide to fine-tune smaller models for specific tasks, which are high traffic tasks, basically. Okay. And of course, I talked about latency, and if you compare the latency, GPT-4 is very, very slow, something that a lot of us in the community understand. GPT 3.5 is much faster. Azure versions are faster than the OpenAI versions. And again, this depends a little bit on the exact plans and stuff like that. But I'm speaking of averages here. On the other hand, if you're using a much smaller model, actually by default, you get much better latency. But if you have things like batch inferencing type of a requirement, you can actually really optimize this. And in that case, you can become even order of magnitude faster compared to your GPT 3.5 and GPT-4 if you're self-hosting them. And which is not a case that you frequently get if you're invoking API call one after the other with some of these closed source LLMs. So now, with the entire presentation, you might feel that I am kind of the school of thought that open source LLMs are going to win and stuff like that. But that's not the case at all. In fact, we particularly believe that the steady state of this world is going to be these open source LLMs, smaller models, more importantly, and the commercial LLMs, the much larger models, are actually going to be coexisting even within a single application, let alone within a large company or a large team, right? And what will end up happening is we will start offloading our specifics, specific tasks to these cheaper, smaller LLMs, and the more ambiguous, complicated tasks will continue to be served using these large language models. Of course, there's a lot of other considerations like latency and all, but we do expect that both of them will start coexisting because these smaller models are not powerful enough that they can solve very abstract questions. But for repeatable small tasks, they're really, really good, right? And one of the other things that we believe here as a company is just in the machine learning world, we have always talked about that ML models are actually a very small component of the overall machine learning applications once you get to the production systems, right? So long as you're building prototypes, it doesn't matter, right? But once you get a production system, ML models become a small part. Similarly, we expect the same thing will happen with large language models as well. Large language models, on the other hand, are really, really effective if you're building prototypes. Like you can literally just take the LLM itself and build an end-to-end prototype and it's going to work fine. But it gets you good enough results, which in most cases is not good enough. Like to build a production grade system, you need a lot of business specific things coming in, which kind of puts so many bells and whistles around your LLM application that it becomes very complex to maintain. And that's where I feel like is going to be the maximum challenge in the adoption of LLMs becoming really fast. So that's a problem that we as a company are trying to solve, where of course we make it fairly straightforward for you to deploy and fine tune some of these open source models, like almost a few clicks. And we come with our model catalog where we have optimized all the models like Llama 2, Falcons, the LoRa fine tuning, QLoRa fine tuning, full parameter fine tuning. So we have done a lot of work around that. But on the other hand, to stay true to our essence, where we believe these models are going to coexist, we have also made some of the singular API endpoints where we make it just as straightforward as changing a single keyword in your API call to switch from a Llama 2 to a Falcon to a GPT 3.5 to some of the other closed source models as well. And besides that, we are also, like when we talk about building LLM applications, we are building the entire ecosystem where you might have some of your company specific services, just API endpoints. You may have some of your indexing jobs, offline jobs or fine tuning jobs that are running under the hood. You may have a bunch of models that you may want to deploy. You may have vector databases that you may need using Helm chart. So there's a lot of these, the entire ecosystem that comes together to build an LLM app. And that's what we're trying to support using the platform that we're building. And one of the other things that we have seen is we're able to do this like roughly 40% cheaper compared to some of the other like cloud providers that try to solve some problems, basically. Okay. And as I mentioned that we have we make the switching cost across these LLMs and also across some of the common dev workflow tools like LangChain almost straightforward. So for example, if you were using LangChain and you wanted to invoke OpenAI, you would be writing like this one line of code. And the only thing that you would change to work, start using some of the open source model is just change this OpenAI to TrueFoundry LLM. And that's pretty much it. Like all the other syntax remains the same in your code, right? So single line of code change and you're able to switch from closed source to open source models. That's about it. If someone wants to get in touch, here's this is where you go. And if you all have any questions, I think we have a minute or two to answer some questions. So we have some questions for comparison. These are non-fine-tuned models. I am not sure which model are you referring to, Sankalp. Then we have a question from Chris. What are the best performing LLMs for coding? So actually, the model that came out of Salesforce is actually really good for coding tasks. Again, a lot of these models, like when we talk about coding, like you have to also be more specific about what languages are we talking about, because one of the things that we have observed with LLMs is they're much better at solving some things like Python and Node compared to languages for which there aren't enough open source repositories, by the way. So like that might matter as well. Then Sankalp is asking, does TrueFoundry allow RAG and fine-tuning on the same model easily? The answer is yes. We have very well developed systems for both RAG and fine tuning, where with RAG, you have a lot of these different components like your embedding models, indexing jobs, vector databases, large language model, open source, closed source. And we have all of these components as accelerators built into the platform. And in fact, to get up and running, we have built out almost like a no code tool where you can literally upload your documents and get the full RAG system built out. But in terms of the actual quality of responses, we believe that as developers, you may need to have some improvements in your data parsers or embedding models, etc., which is the other thing that we continue to support. And same thing with fine tuning as well, where you could literally bring your prompt completion pair data sets, and we would run your fine tuning jobs. We would, if they're long running jobs, we would checkpoint your model so that if the job dies or whatever, if the machine dies, the job can start from checkpointing and metric tracking. So we built a lot of the entire ecosystem around this, by the way. Awesome. Thank you so much. I really enjoyed talking to you all about this topic. It's very close to my heart.